Welcome to DD Maths tutorial, Mathematics Standard, Section C, question number 28. Prove that root 5 is an irrational number. So this is a very common question in all the papers. We are going to prove that root 5 is an irrational number. So we are going to prove it using the method of contradiction. So we are going to assume the opposite of this one. So let us assume root 5 is rational. So when we assume root 5 is a rational number, we will be able to write this root 5 in the form of p by q. So we have learned the definition of a rational number. Rational number can be written as p by q, where p and q are integers. But here, instead of integers, we are going to assume that it is going to be a co-prime numbers. So these p and q are co-prime. So the meaning of the word co-prime is it will not have any other common factor than 1. So the numbers p and q is having a common factor, that is the HCF of these two numbers is going to be 1. P and q are co-prime numbers. So finally, when we are proving, we will be saying that these two numbers p and q have some other common factor, therefore it is going to be a contradiction and our assumption is wrong. So now our assumption is p and q are co-prime numbers, which is the HCF of these two numbers is 1. The next step is going to be squaring on both sides. So when we square on both sides, root 5 the whole square is equal to p square by q square. Root 5 the whole square becomes 5. When we transpose this q square, it becomes 5q square is equal to p square. So we have a theorem. If p square divides a, then p divides a. So we are going to use that one here. So this implies that 5 divides p square and 5 divides p. So this is the first half of the proof. We have come to a conclusion that 5 is a factor of p square, 5 is a factor of p. Now in the other part, we are going to say that 5 is a factor of q. Therefore, 5 is a common factor of p and q, but we have assumed p and q are co-prime numbers where it should not have any other common factor other than 1. So let us do the other part. So 5 divides p. So when a number is dividing another number, so this p can be written as 5 into some number. So C for some number C. So I'm going to take that constant as we are going to multiply 5 with some number to get that number p. So 5 is equal, p is equal to 5c. I am going to substitute, make this as equation 1 and substitute that p value in that equation 1. So we are going to substitute p is equal to 5c in equation 1. So let us substitute that. We have on the left hand side 5q square, which is equal to p square. So instead of p, we are going to write it as 5c the whole square. So it becomes 5q square is equal to 25c square. When we transpose this 5, it becomes q square is equal to 25c square by 5. Once we cancel it, we get it as q square is equal to 5c square. Look at this one. Q square is equal to 5c square. The same way we have 5q square is equal to p square. So from this one we concluded 5 divides p. The same way we can conclude here that 5 divides q. So at first 5 divides q square, 5 divides q. So this says 5 divides p as well as 5 divides q. This says that the HCF of these two numbers is not 1. It is some other number, which is 5 here. So it is going to be a contradiction. So 5 is a common factor of p and q. Therefore, it is a contradiction. Our assumption is wrong and we have assumed root 5 is rational. So root 5 is irrational.